What's up, everybody? My name is Hussein. Today I brought to you the easiest way you can use to understand the principle of conservation of linear momentum. First of all, principle of conservation of linear momentum states that if there is no external force applied on a colliding system, the total momentum before the collision equals to the total momentum after the collision. You know, what are the examples of those external force? External force may be friction, wind, and so on. Let me give you the derivation of the formula used to calculate all the questions involved in principle of conservation of linear momentum. Let's take an example. Two balls have thrown in opposite direction are about to collide. Let me give you two balls here. Here the first ball, and here the second ball. They are thrown in opposite direction. Let's call this ball 1 with mass 1 and this ball 2 with mass 2. Both possess initial velocities. Let's say u1 for the initial velocity of the first ball and u2 for the initial velocity of the second ball. Now this is before the collision. Now during the collision, each ball exert a force. They exert a force each other. Here the first ball during the collision. Ball 1 exert a force on ball B. Ball 1 exert a force on ball 2 and ball 2 exert a force on ball 1. Now, after the collision, each ball have separately moved in opposite direction. Now, this is the first ball with mass 1 and this is the second ball with mass 2. They have now possessed final velocity. This is final velocity of the first ball and this is final velocity of the second ball. Can you give me the reason why these balls have separately moved in opposite side? This is according to Newton's third law of motion, which also states that for every action force there is an equal and opposite reaction force. So each ball have exerted an equal and opposite reaction force to another ball. So that's why they are moving opposite direction. Now the net force of these two balls, the net force of this ball equals to negative net force of the second ball. Net force. Here the net force equals to negative net force. But according to Newton, net force equals to ma. But also ma equals to m. Now multiplied by the acceleration. Here acceleration, since we have change in velocity, we have initial and final velocity. Now we have to put initial minus final velocity. Final velocity minus initial velocity. This is the real definition of acceleration divided by time. This is the real definition of acceleration. Now, remember, we have two masses of the first and second ball, and we have two velocities of the first and second ball. Now, let's substitute. Mass 1, velocity of the final velocity of the first ball, minus initial velocity of the first ball, divided by time, equals to negative mass of the second ball, final velocity of the second ball minus initial velocity of the second ball divided by time. The time of the collision is the same. The time of the collision is the same. Hence, the time will be cancelled out. Now, our equation remains as m1 v1 minus u1 equals to negative m2 v2 minus u2. Open the bracket, it becomes m1 v1 minus m1 u1 equals to negative m2 v2 minus m2 u2. Now put the right terms together. It becomes m1 v1 plus m2 v2 equals to m1 u1 plus, oh sorry, here we have to open the brackets. Here it becomes positive plus m2 u2. Now v1 and v2 are final velocity of the first and second ball, and u1 and u2 are initial velocity of the first and second ball. Now this is before the collision and this is after collision. Now momentum before the collision equals to momentum after collision. Now it becomes m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Thank you for watching my video. Don't forget to subscribe and leave me a comment if the video is helpful or not helpful to you.